You were also asked to graph the function that you found for the tangent line. Remember that we found that the tangent line was y equals 2x minus 8. That will look like this. Now technically it's supposed to be touching the graph at x equals 1, y equals negative 6, and have the same slope. But because I didn't quite graph it right, we don't get that picture. But it should look something like this. And what we end up seeing then is that the graph crosses the x-axis here at x equals 4. We could have also found this value algebraically by solving the above equation for x when y is equal to 0. So we get 0 equals 2x minus 8, 8 equals 2x, dividing by 2 on both sides, we end up getting x equals 4. So from both methods, we end up seeing that x should be equal to 4. Remember that our goal in this is to come up with a recursive formula, or a formula that ends up using this composite function idea over and over and over again to help us find the solution for the zeros. So what we are trying to do is come up with a process f such that we could then plug in a solution to that from a previous function. Well, the function isn't necessarily this f of x that we're working with in this problem. It could be any sort of process that we do to our x values and then solve for them. So what we're trying to do in question 4 is figure out what process did we just go through to get that value x equals 4. So I plugged in x equals 1, or you guys did that, and the output to that was x equals 4. And then now what we want to do is repeat that process again, plugging in x equals 4. But it took us a while to go through and graph and solve and all of that, so now what we want to do is to be able to go through and just come up with some sort of mathematical way to be able to do this without having to go through that process again. So remember what we were doing was we were finding the equation for a tangent line, and then using that tangent line we were plugging in y equals 0 to figure out where it crossed the x-axis. So what I've got here is a general form for the equation of a tangent line, but instead of using our actual f of x value, I'm using f of x1. And instead of using our actual slope value, I'm using f prime of x1. But we can still go through and solve this when y equals 0 for x. So we get 0 minus f of x1 is equal to f prime of x1 times x minus x1. And again, all I've done here is plugged in 0 for y, assuming that we're trying to solve this for x when we're crossing the x-axis, or when y equals 0. To get x alone, I need to first undo this f prime of x1 by dividing, and then I need to go through and add this x1. Now there are other ways to do this, and I saw some of you doing them in class, but that's the form I'm going to follow for this. So on the left-hand side, I really don't need that 0 anymore, but I do need the negative f of x1. And then I'm going to divide that by f prime of x1, or the derivative of our function when plugging in x1. And that is equal to x minus x1. Now leaving that alone, the x, I want to then bring over the x1 to the other side, which means I have to add that to both sides. And that's going to end up giving me negative f of x1 divided by f prime of x1 plus x1 is equal to x. So essentially, if we want to go through and check to make sure that this is right, we can go through with the value of x1 that I gave you originally and see if we end up getting out our second solution of x equals 4. So plugging in f of x1 was negative 6, so we end up getting negative 6 divided by the derivative of our function at x equals 1 was 2. And if I add to that x1, which was 1, this ends up giving me 3 plus 1, which is equal to 4. And that is the actual solution we found from our previous process. So what we've come up with is a way for us to be able to go through and do this iterative process, and then we don't have to worry about graphing, finding tangent line, all of that. We can just use this formula that we've solved for.